it's time to talk about the like operator. Sometimes I get requests from customers and they think that they've got a potential problem. They want me to look into their database to see what's going on. Oftentimes the issue will surround a person, and so they'll give me a name and ask me to look into the data around that person and tell them what's going on. And sometimes I'll put in that person's name into my query and I get rows back. Everything works out fine. But a lot of other times I put in the name exactly and nothing comes back. I get 0 rows returned. So why is this? Well, with SQL, we need to remember that the logic states that columns must be exact to a value, meaning that the content of the field needs to be exactly the same as what we give it. So what happens if a receptionist puts in a name incorrectly, or the person goes by a nickname, or maybe the customer just gave us the name but it was spelled incorrectly? That's a lot of work if we have to track down all the possibilities and make sure they're 100% the right way. This is where the SQL LIKE operator comes into play. The LIKE operator allows us to compare a value against a pattern, meaning that when only part of the value is known, we can put that in alongside wildcards to create a pattern, and that will return the row that we are looking for. The syntax for using the LIKE operator is we specify the column, like, and then we specify the pattern. Let's talk a bit about the patterns you can create with the LIKE operator. SQL provides us with 2 wildcards. First, we have the underscore, which represents a single character. So if you know that there will be a fixed amount of characters, but you're not certain what those characters will be, you can use the underscore symbol. Second, we have the percentage sign. A percentage symbol represents an unknown amount of characters, so it could be 0 to infinity. And you use the percentage symbol when you know the field should contain a certain value, but you really don't know anything else besides that. The most common uses of these wildcards help us to determine some common Microsoft Excel text filtering, such as begins with, ends with, and contains. With what we have covered so far, we can actually use SQL to determine all of these. Let's suppose that the text we are looking for is the word cat. Let's write our patterns for all 3 of these Excel filters. For begins with, because it must begin with the word cat, we first write cat, and then because we don't know how many characters will follow, we're going to choose the percentage symbol as our wildcard. For ends with, because it must end with cat, we write cat, and then we place a percentage symbol in the front, because again, any number of characters can proceed in front of the word cat. And lastly, for contains. For this one, we just know that the field must have the word cat in it. It could start with cat, it could end with cat, it could have cat in the middle of it. Because of this, we write the word cat, and then put percentage signs on either side of the word cat. So that's not too hard, right? Now it's your turn. Let's try out a real world example here. Suppose we have an email address column in the system. Users can sign up for an account from any email provider, but our boss is really most interested right now in users who have Gmail accounts for marketing purposes. He wants you to get him a list of all the Gmail email addresses that are in our system. And for this exercise, let's suppose that there aren't any spaces or other characters allowed after the valid email address. So the question is, what pattern would you write to get this back? Pause the video, and when you are ready, start it up again, and we will go over the solution. Okay, now that you're back, let's talk about email addresses. As most of you know, the syntax of an email address needs to be the account name, the @ symbol, and then the host. In our case, we're looking for emails that are from gmail.com, meaning the host is a gmail.com host. Because we know that it needs to end with that, we should be able to use the ends with pattern by placing the percentage symbol in front of gmail.com, and we're good to go, right? Well, not exactly. As you'll find with the like operator, we need to be as precise as possible. There could be a cool gmail.com out there. We don't want that one included. So what we really want to do is have the percentage symbol, then the @ symbol, and then gmail.com. And that's going to give us the most accurate list, exactly what we're looking for. Perfect. Now that you know the most common uses of the like operator, I think we're ready to start talking about some of the more powerful yet less common tools that we can use with the like operator. Let's suppose that we're asked to find all the fields that begin with a letter, like A through Z. We could go about that by writing a bunch of or clauses and a bunch of like operators 26 times. That's a lot of typing. We don't want to do that. There's a much simpler way to do this. It's with lists and ranges. A list allows for us to specify for a single character a list of all the characters that will cause the row to be returned if it's present. So for example, before we talked about cat, C-A-T, what if we're worried about somebody misspelling it, for example, K-A-T? We could use a list. I put it up here on the screen. Basically, to specify a list, you just use square brackets and then the letters of that list, and you're good to go. Ranges are pretty much the exact same thing, but instead of having to enumerate each and every item, we're going to use a range. So for example, if we wanted to find all the fields that started with 1 through 5, we can do it just like we popped it up here on the screen. So let's do another real world example here with phone numbers. Let's say that our system has a bunch of phone numbers stored, and our boss wants to do a mass phone call to a ton of different users. But unfortunately, the formatting of our phone numbers is different row by row. The program that we're going to use to do our phone callings needs it to be very specific. I put it up here on the screen for you so you can see the format that we're looking for. Our boss wants us to find all the phone numbers that don't follow this format so we can go ahead and fix it and get ready for this massive phone calling that we're going to do. Where do we begin? Well, first, we can start by finding all of the good phone numbers. Luckily, SQL allows us to use not like, which basically means if the pattern does not match up, let's return that row. So let's look at the pattern of the properly formatted phone numbers. I've got it here up on the screen. And really at this point, we've got all the non-numerals in place. Our parentheses are in place, and our hyphen and our space is in place. We just need to turn those X's into numbers, and then we're good to go. We can easily do this by replacing each X with a 0 through 9 range. So the final pattern will look like this, and I put it up on the screen. I know that it looks like there's a little bit going on here, but it's really pretty simple. We're just using ranges, 0 through 9 ranges for each of those numbers. So finally, we're going to just say not like this pattern. And now we're going to get all the improperly formatted phone numbers, and we can get that list to our boss, and she'll be very, very happy. Well done, guys. I hope that you've learned quite a bit about the like operator from this lecture. The last thing I want to talk about is performance, because it's always important to remember performance with our SQL queries. This performance tip has to do with indexes. I know that a lot of you don't know about indexes much, but we're going to go into indexes much later. So for this item, just remember the principle, which is begins with is faster than contains. So cat percentage sign is faster than percentage sign cat percentage sign. This has to do with indexes, and a lot of you, again, aren't familiar with it. We'll definitely hit on this point in the future, but for now, when you're writing your queries, you can remember that. Begins with is going to be faster than contains. It's going to save you some time with performance, and that's always nice when you're on a big system, and it can save you minutes, which is fantastic. So in short, the like operator is very powerful. It's extremely valuable when you are unsure of the exact contents of a field, but you need to get used to it because it's something you will need for sure in your SQL tool belt.